Two guys were playing ping pong. Sadly, one of them was not very good at it. We will call him Frenchie. Frenchie decided to hit the ball as hard as he could, where it ricocheted off a wall and into a vase. Luckily, his friend, who we will call Connor, was smarter than his impulsive friend. Connor had in the past decided to measure the vase. It was 8.741 inches tall and was filled at a rate of 10 milliliters of water a second. Connor also took the measurements of the height of the water for every few increments. Connor also luckily had his handy-dandy calculator to plot the points and find an equation that best matched the correlation between the radius of the vase at a point and the height of the water. First and foremost, though, he plotted the points and applied a best fit equation. The equation showed the height of the water at a specific radius and vice versa. Connor had also made another smart idea. By using that equation, which gave him the radius of any given height, he could find the volume of the vase. What he found was the vase had a volume of 256 milliliters, which made sense, considering it took roughly 26 seconds to fill at a rate of 10 milliliters a second. Now, Connor had a relationship between height and radius, but that wasn't the only thing he could find. By taking the equation for the radius and doing the derivative of it, he could find how the radius changes. This equation would be able to show whether the radius of the vase would be increasing or decreasing. Now, don't forget Connor has his friend Frenchie over, who started this entire mess. Frenchie honestly isn't quite sure how his friend Connor managed to do all this. To Frenchie, none of this really made sense. Now Connor, hearing this, explained it to Frenchie. The idea is the volume of the vase is made up of an infinitely amount of circles. By adding these areas together, you could get the volume. Now, of course, it wasn't as simple as just adding circles, as each circle had a different radius. At this point, Frenchie was lost, and frankly, he was ready to grab a hammer and break the stupid vase open to get the stupid ping pong ball. But Connor stopped him. He pointed something out to Frenchie. When they had gathered and plotted data points, they had found the best fitting equation for it, and this equation essentially represented the changing radiuses. By having this changing radius, they could go back to the idea of a circle. A circle has the area of pi r squared. In this case, r was represented by the equation. From here, it was a matter of adding up the infinitely amount of circles in between 0 and 8.741, which represented the height of the vase. This is how the integral came to be used, as it essentially added them together. It was starting to make sense to Frenchie now, but still he had questions. "So Connor," Frenchie asked Connor, "if the integral is the volume, then what does the derivative get you?" Connor shook his head. "You know, Frenchie, you should pay more attention. I talked about this before. Anyways, let's go back to the equation. Consider that it essentially gives correlation between radius and height. Well, since we all know that derivative goes back to the slope, the derivative will tell us the change in the radius of the vase. This is good, as it allows us to tell when a vase has a change and how extreme the shape of it is. That can be useful if you're ever given characteristics of a container, but you're not actually given the actual image of it." "You know, Connor, I've learned a lot today," Frenchie told Connor. "But I still have one issue," he continued on. Connor could only wonder what he still needed to explain to him. That was until Frenchie merely pointed at the vase. "Connor, all that learning was good and all, but our ping pong ball is still in there. So, how do we get it out?" Connor was finally stumped. But Frenchie? He had a genius plan.